Let's check and see what's going on with the problem of the day. We've got a solve an inequality. That means an inequality. Some of you say, well, what do you mean? It says 5 times, we're going to put in parentheses, x minus 3, means distributive time here, less than or equal to 7x plus 6. Again, that's a less than or equals to in the mark there in between. We have x minus 3 in the parentheses, got to be dealt with. And we may have some other things to deal with as we look at that. So let's do a solve on it. And to make things a little more interesting, we're going to eventually put a number line down here and graph it out, see what happens. First of all, I mentioned distributive property. We're going to start with this 5 because there's parentheses saying, hey, multiply me through. And we're going to do just that. We're going to take the 5 times the x, and while we're at it, go ahead and that 5 times the minus 3, which is going to leave us with, well, it's not going to leave us, yeah, it's going to leave us with it, yeah, because it's going to change. It transforms, if you will. We now have 5x, then we got to multiply the 5 times the minus 3, which is going to be minus 15. Keep that less than or equal to right there humming, and we've got plus a 6. Right there we have it. So that's what happens first. Now it looks like an equation. If I had equals in there, most of you go like, yeah, do this, do that, do this. We're going to do the same thing. Although we're going to have to worry about something at the very, very end, but just hang on to that thought, all right? Now let's do a minus 7x because we want to move the x's, get them together. So in order to get rid of that positive 7x, we're going to subtract over here. And that, my friends, is going to leave us with negative 2x minus 15. Over here, say goodbye to those x's. And it's still a less than or equals to. That has not changed. And we have a 6 left over. Looks like those good old pre-algebra equations, you know? So let's add that 15 over there. Want to do that? Why not? Let's do that. We're going to add that 15 over. And it looks like we're going to add 15. Like I said that a few times, haven't I? And we're going to have a negative 2x left over, less than or equal to 21. Now, I don't want to mess up my number line here, so we're going to move it out just a little bit this way. At this point, let me rewrite. We've got negative 2x less than or equal to 21. Everybody got the arithmetic right so far? Nod with me. Of course, I can't see it, can I? So I've got 5x minus 15 starting off with 7x plus 6. Looks good. Now we got to make sure we did our adding correctly. That was a positive 6 and a positive 15. That was easy. 21. Over here, remember, 5x minus 7x gave us a negative 2x. So now we're ready to see if the miracle is going to occur. What's the miracle? Miracle is going to be dividing by negative 2. Now this is where you got to be very careful, because when you change this division by a negative, you're changing, oh my goodness, you're changing signs on both sides. What was negative has now become an x, positive, and what's positive over here has now become, negative 10.5, and we've got to be very careful. We got to change that less than to a greater than. Switch the sign, shift the inequality, because all of a sudden, what was less than is now going to be as a greater than situation. So we're going to pick it up here at negative 10.5 somewhere along the way there. Put a negative 10.5 on that number line. Open or close, think about it. What do we got? If we had just greater than, we would be only open. We would be leaving negative 10.5 open. But the way it's going to work here, we're going to need to close it. And now it's pretty easy to figure out which way we're going to shade. We thought we were going to be shading to the left, but guess what happened? We divided by the negative. We shade to the right, because now it's a greater than situation. And let's run a little test here. We know equals is going to work. Well, we hope it does. If you put a negative 10.5 in there on both sides, you will get the equals part. But we're interested in, did we shade in the right direction? And you know what? There's an easy number to figure that out. Move up a little ways, all the way up here. We'll test 0. Because see, if 0 works, everything that is in this shaded range will work. And that's where we're going to go. So we put a 0 in both places. I'm going to get 5 times negative 3, which is a negative 15. Whew. And negative 15, is it less than 6? It certainly is. And in fact, any number I pick that is above negative 10.5, including a negative 10.4, those of you who really want to try out this thing, we'll still have a true statement with the less than part. But we can't go beyond here. We can't go beyond 10.5 because that's the equals part. Anything to the left is going to throw this inequality off that we started with. So that's why it's always good to check. Pick a solution. Pick a number that's in that shaded region and see what happens with it. And you know what? This one worked out great.